Welcome to section 4.4 Model Privacy Risks. In this lesson, we'll explore how machine learning models can unintentionally leak private information about the data they were trained on. In this lesson, you'll be able to define membership inference attacks, understand risks of overexposed model outputs, explore mitigations such as differential privacy, and finally, link privacy to trustworthy AI deployment. Alright, so let's get started. So, membership inference basics. A membership inference attack happens when someone tries to determine if a specific record, such as your medical file or financial history, was part of a model's training data. Attackers do this by carefully analyzing the model's outputs, particularly the confidence scores it assigns to predictions. If the model is much more confident about certain examples, it could indicate that those records were in the training set. This poses major risks for sensitive datasets where where merely revealing membership can compromise privacy even without exposing the full data. Models leak information when they overfit, meaning they memorize the training data instead of generalizing from it. In this state, a model can inadvertently store traces of individual records. When it outputs very precise confidence scores, attackers can compare how the model responds to known and unknown inputs. Models made available through public APIs, where anyone can query them repeatedly, makes this risk even higher. In other words, the more detail you expose and the less you control access, the easier it becomes for attackers to probe for private information. In healthcare, a membership inference attack might reveal that a patient's record was part of a clinical trial, effectively exposing medical conditions without consent. In finance, it could confirm whether a person appeared in a fraud dataset, carrying obvious reputational and legal consequences. Even if no sensitive details are directly disclosed, the perception that an AI system leaks private information can erode public trust. Once users doubt that their data is safe, adoption suffers and organizations face regulatory scrutiny and reputational damage. Mitigation strategies. There are several effective mitigations, such as differential privacy, which adds carefully calibrated noise during training so the model learns useful patterns without memorizing individual records. There's regularization techniques like dropout or weight decay, combating overfitting, which makes it harder for attackers to distinguish whether a record was in training. And finally, there's limiting outputs, which is crucial. Models don't always need to expose raw confidence scores or probability distributions. Providing only the necessary predictions reduces the attack surface significantly. Together, these strategies balance utility and privacy, making models both functional and resistant to leakage. Building trustworthy AI. Protecting against membership inference is more than a technical safeguard. It's a cornerstone of responsible AI deployment. Organizations that implement differential privacy, strong regularization, and limited exposure show they take user trust seriously. Just as importantly, these defenses reduce regulatory and legal risks for the organization itself. But defenses aren't one time fixes. Models evolve, attackers adapt, and monitoring for potential leakage must be ongoing. Building AI systems that respect privacy isn't just good practice, It's essential for creating technologies people will trust and adopt at scale. All right, so to close, remember that membership inference attacks are real and pressing privacy risk. They thrive on overfitted models and overly detailed outputs, but can be countered, with differential privacy, strong regularization, and limiting exposed information. Ultimately, privacy protection is inseparable from building trustworthy AI systems. We'll continue building on these concepts in the next lesson. Until then, thank you for joining me.